So this is like the big kahuna. We have a 3 by 3 system here. But just like with the other stuff, we are trying to get down to one equation with one unknown. And the way we do that, well, here we have 3 equations with 3 unknowns. Well, if we want to get down to one equation with one unknown, we're going to start by just getting rid of one of these variables. So we'll take the system that has 3 equations and 3 unknowns, and we'll get it down to 2 equations with 2 unknowns. So just you have to pick something to get rid of. These are you can get rid of all the x's, maybe all the y's, maybe all the z's. It doesn't matter. Just looking at this code right now, I'm thinking that it'll be easiest to get rid of the x's first because I can see that these will already knock each other out, and then I can easily manipulate this one to make it the opposite of this one. So what's different about this is we're going to use elimination techniques like we did before, but we're going to use some equations more than once in this process. So before I can get this down to one equation with one unknown, I'm going to do 2 with 2 unknowns. I'm going to start by taking these 2 equations right here. I'm just going to combine them, and I'm going to get rid of the x's. So if I add these 2 equations together, the x's cancel. 2y and y combine to make 3y. And then, of course, negative z and 3z combine to make a positive 2z. And they're going to equal whatever you get when you combine this with this, which is, of course, negative 5. So now I'm going to use whichever equation I haven't used yet. So I'm going to use this equation, and either one of these two, doesn't matter which one, I think it'll be easier to use this one because they're already opposite signs, but it really shouldn't matter. I just need to make these guys have opposite coefficients. So I need a positive 3x to counterbalance this negative 3x. So just to be clear, since we use these 2 equations to get this, I need to use the equation I haven't used yet in either one of these, and I have to eliminate the same variable, the x, again. So what I'm going to do in purple is take that first equation and triple everything. So that's 3x, 6y, negative 3z, and negative 9. The last equation, I'm just going to recopy that down the way it is. And I'm going to go ahead and combine these, and just like I need, these are going to be eliminated, so I got rid of the x. These combine to make a positive 2y. These combine to make a negative z. And then this is going to combine to make negative 8. And my second equation is going to be 2y minus z equals negative 8. So the good news is this looks like something we've done a bunch of. We're going to solve this system using elimination. And you guys, I'm going to pause this. You know the steps from here. I'm probably going to get rid of the z's because that'll be the easiest thing to do. But pause it, do the work, see if we agree. So my plan was to leave the top equation alone, and then to double all those things in the second equation to make these opposites. And that's going to give me a 7y equals a negative 21. From there, I can find pretty easily that if I divide both sides by 7, that y equals negative 3. Now I'm going to take this, and I'm going to start work my way back. If I know y equals negative 3, I can pick either one of these and find z. I'll use this one, I guess. I'll do this in blue. So that'd be 2 times negative 3 is negative 6 minus z equals negative 8. So if I solve that mentally, I'll add a 6 to get negative z equals negative 2. So z is going to equal positive 2. Now I know this. Now with this y and with this z, I can go back up into any one of these 3 equations with those values and find the value for x. I'm going to pause the video while I do that. You go ahead and do it ahead of me. And now finally, this is me using the first equation with the y value that we found and the z value that we found plugged in here. And we're just going to solve this equation out and figure out that x is going to equal, this we combine to make negative 8, add 8, but both sides give me 5, and to be a ordered pair of 5, negative 3, 2. Or maybe Alex has you write down the x and y and z value, but in the event that they don't, you should put it in alphabetical order. And then, if you want to make sure you're right, you can take these values, and since I used this one to find the x, check it in either one of these two equations and see if it works. So for example, if negative 5, if I take negative x, so negative 5 plus negative 3 gives me negative 8, plus 3 times 2, which gives me 6, it'll equal negative 2. So I know this is totally right.